we'll continue our discussion of drawing tile ornaments with Python image library in this screencast. So just to remind you, a tile ornament is defined as an RGB image divided into rows of square tiles. So we define these three color variables, constants, you can call them red, white, and blue. O stands for outline. And here's an example of an ornament that has 10 rows, and each row is encoded in terms of tile runs. So, for example, row 0, row 1 has one red tile with the blue outline, then 6 followed by the run of 6 white tiles with the blue outline, and then it is concluded with a run of one red square tile with the blue outline, and so forth. So and now let's take a look at the source code. There will be a link to the source code in the description of this screencast. So this is a simple utility function, square bottom right, that computes the coordinates of the bottom right corner of the square, given the coordinates of the top left and the side of the square. So top left xy is a tuple, and it returns the tuple. This is a function that uses an image draw object, so this type image draw, to draw a square. So takes its top left side, fill color, the color of the interior, and outline color, and uses the rectangle method of the image draw class to draw the square, right? Well, a rectangle actually. This is the function that draws a tile run, takes an image draw object, and here's a tile run, and it takes the row number, which is the number of the row in the image where that tile will be drawn, and the tile side. So these variables, current x and y coordinate, are the coordinates of the current top left. The top left of the current tile. Current x initially is 0, and then y coordinate is tile side times row number, because we can compute that because we're drawing squares, right? Square tiles. So then inside of we just iterate through the row run. So extract the run length, the fill, and the outline. So remember, each run is a 3 tuple. And then inside called draw a square. Right, why we have not run out of square tiles, we call draw square, and then decrement the square count, and increment the current x, the top left coordinate of the next square, by the tiles, by adding the value of the tile side to it. And this is the function that draws the entire ornament. The tile ornament takes the image path, the image size, the ornament as encoded above, and the tile side, and the image x and y must be in multiples of the tile side. It defaults to 0, 0, but they must be multiples. So we create a new RGB image, associate an image draw object with it, and then zip ornament and the length of the ornament, so that there is a mapping between ornament rows, run lengths, rows, and the number of the rows, and inside called draw tile function, row run, row number, extracted from the zip. And the tile side, and then afterwards we delete the image and the iDraw object. And this is another utility that uses the image draw object, without generating any and saving any images. So these are the tests. Let's talk about the tests. Like code test. There are two ornaments. So the first ornament and the second ornament. Okay. This ornament, the first ornament, has 10 rows, each of which has 10 tiles, and well, those are the color variables. Um, let's say if you add one and 8 and 1, so you end up with 10. So the number of tiles in each row is the same. It's just the run lengths are different. And the second ornament has 9 rows, each of which has 31 tiles. So if you add 5, 1, 3, 1, 11, 1, 3, 1, and 5, they add up to 31. So like so the last row has just one big run of 31 red tiles with the blue outline. Um, okay, and then there's a couple of test functions. So the first one tests the function draw square. So we can run it in the Python shell, and it creates an image. So here's just one square. Let's go and run the second test. That actually tests draw tile run. We can define the row run, right? So 10 tiles, and then we can run this image, and it will generate another bitmap test underscore 02 .bmp. So this is what it looks like. So 1 red, 8 white tiles, and 1 red at the end. So let's test another one. So let's just generate. Oops, it's the wrong directory. I forgot to type tile ornaments. Okay. Right. So that's another tile. That's ornament 1. So let's test 4, which is ornament 1, but scaled differently. So it's a larger rendition of ornament 1. Test 05, that tests creates an image with ornament 2, and pay attention. So the image size is 110 pixels by 90 pixels, and they are multiples of the tile side. So because the ornament has 31 tiles in each of the 9 rows. So this is ornament 1. Right. And let's do another test. Just a larger rendition of ornament 1. So 620 by 180, and the tile side is 20. So it'll just be, yeah, so this is what it looks like. And there's a final function. You just run all of them at once, all of the tests at once.